So we are taking our knowledge of implicit differentiation one step further, and we're adding trig. Honestly, implicit and trig happen pretty frequently. It's kind of like the chain rule. It's one of those things that trig problems just naturally ebb and flow into having implicit differentiation. So our goal is to find the derivative of x cubed y plus y cosine x equals to 10. So what we want to do is pay attention to the fact that we have a product rule in the first part. So you have x cubed y. So you need to do first times derivative of the second plus the second times derivative of the first. And at this point in time, you no longer need to put dx dx after the x's, because we now know that when you take derivative of y, you get dy dx because we're deriving with respect to x. And then if we take the derivative of x, we get dx dx, which just becomes 1. So first times derivative of the second plus second times derivative of the first plus another product rule. So it's first times derivative of the second plus second times derivative of the first equals 0. Because 10 is a constant. So now, same goal as before. We need to get dy dx on the left and everything else on the right. While moving my dy dx's and my other stuff, I'm just going to reorganize the variables and terms as well. So this would be x cubed dy dx plus cosine x dy dx. And then as I move over the y3x squared, I'm just going to make it so that the coefficient is out in front, is positive, so to move it to the other side it becomes negative. And then similarly, the negative y sine x is going to become positive sine x. And then once everything without a dy dx is on the right, and everything with a dy dx is on the left, we can take out that dy dx as our GCF. Divide everything over. Because you're adding and subtracting in both the numerator and the denominator, you cannot simplify. Neither have a GCF or like terms. Okay. Example number 2. Find the derivative of sine x plus y equals y squared tan x. So now this one is different than the previous one because the sine has a chain rule within it because you have x plus y inside the angle of the sine. But now it's implicit and chain because the sine has two variables. So we apply the chain rule to start, which says derivative of the outside. So derivative of sine is cosine. Times the derivative of the inside. I tend to put the inside in brackets because otherwise we drop or lose things. So derivative of x is derivative of y is, so now that cosine x plus y is technically going to be distributed to both the 1 and the dy dx. And on the right side, I have a product rule. So I have the first times derivative of the second plus the second times derivative of the first So on the left side, I need to distribute the cosine. Next, I need to move dy dx to the left, everything else to the right. And for me, I know I'm going to GCF out the dy dx, and I just kind of skip that step now. You can totally leave it as that extra step. I just run out of board. So here's where you have to be really cautious. You want to make sure you put the cosine x plus y with parentheses around your x plus y. We have a tendency to lose those parentheses. You also want to make sure you're really cautious of your sine. When you move over the tangent, it becomes negative. When you move over the cosine, it becomes negative as well. And for our final answer, we have y squared secant squared x minus cosine x plus y over cosine x plus y minus 2y tan x. And the derivative of my sine x cosine y equal x. So I group the 5 and the sine x together. So it's a product rule. So it's first times derivative of second, derivative of cosine is negative sine. And then because it's a y, it's negative sine of y, dy dx. Plus cosine y times derivative of 5 sine x. So that's 5 cosine x. And this time, since it's equal to x, derivative of x is 1. Cleaning it up, I have negative 5 sine x sine y dy dx equals 1 minus 5 cosine x cosine y. Now, because the denominator in this problem is a singular term, we can think of this as two separate fractions. So what that would do is allow you to say, okay, well, 1 over sine is really cosecant. So this is kind of like negative 1/5 cosecant x cosecant y. And then you'd have minus 5 over a negative 5. So a negative over a negative would become a positive. 5s would cancel. And cosine over sine is really cotangent. So this would be cotan x cotan. Again, it wouldn't be wrong to leave it the other way, but somehow this just looks nicer. Y squared secant xy. So now, in the last one, we had chain and implicit with the sign, but they were adding together. So now we have secant xy, which is going to be chain and implicit, but it's a product rule inside instead of a sum. So we're just going to see the difference with having a product rule inside. So we have the product on the left. So we have first times derivative of the second plus second times derivative of the first equals derivative of secant, which is secant xy tan xy times the chain rule part, which is the product of the inside. So that's first times derivative of second plus second times derivative of first. So once again, you have to distribute the outside to everything inside. So we have 2xy dy dx e plus y squared equals x secant x y tan x y dy dx plus y secant xy tan x. Moving dy dx is to the left, everything else to the right. The only thing that our notes are lacking, and I kind of printed another handout, we never talk about finding a derivative at a point for an equation of a tangent line. So I have another example that talks about that. It's on the back of the handout. So I'm just going to give it to you. We're just going to look at the one on the back. So I meant to copy and paste it over to your notes, and then I printed them, and I was like, well, I'm too lazy. I'm just going to print it. So I want to find the equation of the tangent line. So we have find the equation of the tangent line at the given point, x to the fourth plus y squared equals 3. So we'll also look at one with trig. I'll probably do number 4 above, and I'll just make up a point on the unit circle. But again, reiterating and referring back to all of these, start by taking your derivative. So you have 4x cubed plus 2y dy dx equals 0. Now, you have two choices at this point for finding the equation of a tangent. If it's easier to solve for dy dx and then plug in numbers, that's option 1. So option 1 is solve for dy dx, exactly like we've been doing. So you say 2y dy dx equals negative 4x cubed, divide by 2y, and we say dy dx equals negative 2x cubed over y. And then at this point, you evaluate. So then you would say, okay, dy dx at the point 1 negative root 2 is negative 2, 1 cubed over negative root 2. Negative cancel, 1 cubed is 1. So you get 2 over root 2. And if you don't like that, you could have 2 root 2 over 2, which is root 2. Going back to like the trig days and rationalizing the denominator. Personally, I just like that it becomes root 2 because I don't like a fraction. So then that represents your slope of your tangent line. You plug in to point slope form. And then you simplify, you get like root 2x minus 2 squared. Option 2 wasn't much different. All you're going to change is how or when, and you guys can do this in the space below, I just can't scroll, you plug in. So all that changes now is when you plug in. So the alternative is up here to take the 1 and the negative root 2 and plug them in now. So the 4, 1 cubed plus 2 negative root 2 dy dx equals 0. and then you solve for dy dx with numbers instead of variables. So you can see you ultimately end up with the same answer. So there's not a right or a wrong way, there's just a different way. And sometimes on the more complicated problems, yes, plugging in numbers earlier is easier. So like, if we flip it over, we can look at 1 or 2. Really doesn't matter. I feel like you have more space for 1. So ultimately, if we pick number 1, we'll start with an x value. So if I want to pick an x value that makes sense, I want to pick an x value that I can plug in to sine, and it's going to be like a value that's a unit circle value. So like if you plugged in pi halves, then you get 3 pi halves. So we can do the sine of 3 pi halves. If you plug in pi, like, so you just want to pick an x value, like, or I want to pick an x value that makes sense. So let's say we just pick pi. That way there's differentials. So now, that's good and dandy, but only knowing x is only part of the problem. In order to be able to find an equation of a tangent line on y values, we need to know y. So if we plug in pi for x, we could solve for y. Sine of 3 pi, so sine of pi is the same as sine of 3 pi. I mean, the circle value, so sine of pi is, yeah, straight. I made it go away. So you have 7y squared equals 12 minus y to the 4th. So then moving all this over, you have y to the 4th plus 7y squared minus 12 equals 0. So that's really just kind of like a quadratic, but in quartic form. And praying it's factorable. Not. Making up that problem as we go. So now this can be plus 3 plus 4. And our y will just match. You only need one y back. So we're going to say that y is equal to plus or minus I squared equals 3, and y is equal to plus or minus 2i. So we're just going to make it the positive 2i for our problem. I just don't have it in calculator. I just couldn't figure it out. Okay? So that's my ordered pair. So that's how you would find an ordered pair. Typically, if this was AP making me find it, you would have nice numbers. I just made it up. So now we need our derivative. So 14y 2y dx plus cosine 3x times, don't forget your chain rule, 3. So once we get into implicit, but everybody's like, oh, I forgot the chain rule. Equals negative 12 becomes 0 minus 4y cubed 2y dx. Get dy dx on the left, everything else on the right. And here's what I was kind of talking about. Instead of really solving for dy dx all the way, I mean, honestly, I said get it on the left and get it on the right. You could have actually stopped here and just started plugging these in. I have a tendency to at least get it to this point. So now you would say 4 times 2i plus 4 times 2i cubed dy dx equals negative 3 cosine dx. 3 pi. Cosine of 3 pi is negative 1. Negative 1 plus negative 3 is positive 3. 8i. This becomes 8. 2 is cubed. We get 8i cubed. 8i cubed is really negative I. We get negative 8i times 4 with negative 32i. I cubed is negative I. What's the weird rule? You don't have to make it.